Hello everybody, welcome to the LMS initiative of Department of Collegiate and Technical Education. Myself Rekha T, Selection Grade Lecturer, Department of Chemical Engineering, ST Government Polytechnic, is here to present the first session of the course Mass Transfer 1. So Mass Transfer 1 is the course that is included in the 5th semester curriculum of Diploma in Chemical Engineering program. So before we start the session, let me give you a brief idea of objective of having this course as a part of our curriculum. Okay, so mass transfer operations are very important operations that are required in industries for various applications. So these are basically separation operations that are playing a major role at various levels, right from the purification of raw materials till the purification of products obtained. So it's very important for a chemical engineering student to understand the principles of these operations, know their applications, and so that he can utilize the knowledge in his future endeavors. So the objective is to make the student to summarize the principles of various mass transfer operations used in industries and know their applications. So before we start the session, so let me briefly tell you the organization of concepts in the first unit. So we have 6 units in the course. The first unit is about principles of mass transfer. So under this unit you are going to study the fundamentals of mass transfer operations. So that is, what is mass transfer, then what are mass transfer operations, what are the different mass transfer operations, and what are the operations and how they are classified and how they are conducted, and what are the different methods of conducting mass transfer operations. Okay, let us start the session. So quick look at the topics that are going to be discussed today. So the first important thing is to know about what are mass transfer operations. That will be discussed under Introduction to Mass Transfer Operations. The next thing is the classification of mass transfer operations, and the next thing is direct contact of two immiscible phases. So this is the one category under the classification of mass transfer operation, which is an important category. So we will be seeing the important operations that we are going to study under this category. So this is the definition of mass transfer. So if a concentration gradient exists within a fluid consisting of two or more components, there is a tendency for each component to diffuse or migrate in such a direction as to reduce the concentration gradient. This process is known as mass transfer. It means whenever you have a material, say a fluid containing a group of components, say two components A and B, then if the concentration gradient, means if the concentration of one of the components, say A in this case, is different in different parts of the fluid, then the component A and B both will have a tendency to move in such a direction so that the concentration difference what exists in the system gets reduced, finally becoming zero. Okay, so this basic process is known as mass transfer process. So what are mass transfer operations? All of you are familiar with the unit operations concept, right? So what are unit operations? The operations in a process where the material is undergoing some form of physical change, the required physical change, right? So mass transfer operations are one type of unit operations which are carried out for separating the components of a mixture involving a transfer of material from one homogeneous phase to another, utilizing the differences in physical properties such as vapor pressure, solubility, diffusivity, etc. So these are called as mass transfer operations. Okay, means there exist two phases in the operation and the two are contacted with one another. So due to that contact, a concentration gradient established, then the material gets transferred from one homogeneous phase to another, and that transfer depends upon the difference in properties of the components present in the given mixture. The properties that are utilized here for effecting separation are vapor pressure, solubility or diffusivity. So every separation or a transfer operation requires a driving force, right? So for mass transfer, the concentration difference or concentration gradient is the driving force. So the driving force for mass transfer is the concentration gradient in the same way as the temperature difference or temperature gradient is the driving force for heat transfer. Let us now see some of the characteristics of mass transfer operations to understand its nature. The mass transfer operations are characterized by the transfer of material from one homogeneous phase to another on a molecular scale. So for example, if you consider the evaporation of water from a pond into the air that is flowing as a stream over its surface. So then how this evaporation occurs? First, the water molecules at the surface gets vaporized, and these water vapor molecules will first diffuse through the molecules of air that is present on the surface of the water, and then gets diffused into the air stream, and from there they are carried away by the flowing air. Okay, so such kind of transfer on molecular scale is observed in all mass transfer operations. So it's not the bulk movement as a result of pressure difference as in the case of pumping a liquid through the pipe. So all of you know how a liquid flows through the pipe, right? So we apply pressure by means of a pump, then liquid flows from one point to another point in a piping system. So that is the bulk movement of a material. So mass transfer is not the bulk movement, it is the movement of molecules on a molecular scale. So it is a transfer of mass as a result of concentration difference or gradient, the diffusing substance moving from a place of higher concentration to a place of lower concentration. So mass transfer operations include the following important techniques: distillation, absorption, liquid extraction, drying, crystallization, leaching, solid extraction, then adsorption, ion exchange. All these are coming under the mass transfer operations, which are very, very important for a chemical engineering student. So how mass transfer occurs in various mass transfer operations? So these are some of the important ways or the important examples how mass transfer occurs. So mass transfer may occur in some operations in only one direction. For example, gas absorption. Gas absorption is that operation where a gas mixture is contacted with liquid solvent and some components of gas mixture gets transferred to liquid phase due to the difference in solubility of those components with the other components of the gas phase. So there is a transfer from gas to liquid phase only one direction. So that is what is known as mass transfer occurring in one direction. Okay, so in some other operations, the mass transfer occurs in both the direction, that is in the forward as well as backward direction. For example, distillation. So distillation is that operation where components of a liquid mixture are separated using thermal energy. That is, the given liquid mixture is vaporized and the vapor is contacted with the liquid phase so that the exchange of components takes place between the two till you get a vapor that is pure in one single component. So then you can separate out the vapor as a product. So here, when the two phases are contacted, some components gets transferred from liquid to vapor phase and some other are getting transferred from vapor to liquid phase. Usually, the one which are having higher vapor pressure are undergoing transfer from liquid to vapor, and the components having low vapor pressure are getting transferred from vapor phase to liquid phase. So this is the operation of distillation where components gets transferred from liquid to vapor as well as vapor to liquid, that is in both forward and backward, that is opposite direction. With simultaneous heat transfer, That is, some mass transfer operations also involve heat transfer, which is very important. For example, drying. So drying is an operation that is carried out to remove moisture from wet substances in industries. So here the heat transfer plays an important role. So in fact, the heat transfer is as much important as the mass transfer in the operation. So because we need to remove the moisture, we need to evaporate the moisture, so heat is required. So similarly, in other operations like humidification also, we see simultaneous heat transfer along with the mass transfer. So some mass transfer operations also involve chemical reaction simultaneously. For example, gas absorption operation with chemical reaction. So one example let me cite here to understand the chemical reaction occurring with the mass transfer operation. So in the manufacture of nitric acid, which requires a reaction between nitrogen dioxide and water, the nitrogen dioxide is first absorbed by water from a mixture of gases. Then after absorption, it reacts with that, then forming a new substance, that is nitric acid. So it is first the absorption operation that is taking place, which is a mass transfer operation. Then there is a chemical reaction producing a new substance. So this is a typical example for mass transfer occurring with a simultaneous chemical reaction. So next thing is, mass transfer may involve exchange of one component or a group of component. So it may be either a single component exchange or a multi-component exchange we observe in mass transfer operations. So also the mass transfer operations can be carried out isothermally or non-isothermally. So following phenomena must exist in all mass transfer operations. So these 3 points are common in all mass transfer operation. The first one is, at least two phases must come into contact with each other. So as I said before, all mass transfer operations involve two phases, and the two phases must come into contact with each other in some way. Then when contact is established, then concentration gradient is set up, then the material starts flowing from one phase to another. Then that part of material flow, what is occurring in the process, is always must be by molecular motion or molecular diffusion. So that means whenever a component gets transferred from higher concentration point to lower concentration point, the molecules of the substance diffuse in two different mechanisms. So one mechanism is, the molecules diffuse from higher concentration region to lower concentration region by the virtue of thermal energy, that is due to their random thermal movement. So that is called as molecular diffusion or molecular motion. Whereas if the diffusion of molecules of the substance occurring from higher concentration region to lower concentration region is due to some external aid like agitation, stirring, convective movement of fluid, then it is called turbulent diffusion or eddy diffusion. So what I am saying here is, some part of the material flow out of the entire material flow is always by molecular motion, means there is a combined effect of molecular motion or and the turbulent motion in the total material transfer involved in a mass transfer operation. Since the basic mechanism involved in mass transfer operation is same, some similarities are observed in all mass transfer operations. So these are as follows. Equilibrium is reached between the phases after a sufficient long period of contact. That means we have two phases, we are bringing them into contact with each other in order to conduct mass transfer. So when they are contacted for a sufficient period of time, then a state will be reached where the diffusing substance will be uniformly distributed in both the phases, and also its chemical potential in both the phases will be equal. So that is a state when we say that equilibrium has reached between the phases. So that is the end of the transfer process. No longer composition change can occur after equilibrium has reached. So this is common with all the mass transfer operations. So next, the material flow is combined effect of both molecular diffusion and turbulence. So this point we discussed in the previous slide also. The total material flow in a mass transfer operation is a combination of both molecular diffusion as well as turbulent diffusion. So this important, one more important thing is there is no resistance to mass transfer at the phase interface. The interface means it is the boundary, that is where the two phases are coming into contact with each other. Okay, so there may be resistance within the phase from which the material is undergoing transfer. Maybe there is resistance in the other phase into which the material is getting transferred, but at the interface there is no resistance to mass transfer at all. Then the rate of mass transfer is evaluated by deviation from equilibrium concentration. So when a mass transfer is taking place, equilibrium concentration is reached after sufficient period of phase contact. How far is the given system from this equilibrium condition decides the rate with which the transfer of component occurs between the phases. Okay, so these are the common things, important similarities between the different mass transfer operations. So that completes the characteristics of mass transfer operations. Now we'll take up the topic of classification of mass transfer operations. So let us now see what are the categories under which the various transfer operations are grouped. There are four major categories. The one is direct contact of two immiscible phases. The second one is phases separated by membranes. The next is the direct contact of miscible phases. Then we have the use of surface phenomena. So direct contact of two immiscible phases is the important category which involves or includes some of the important mass transfer operations. So majority of operations are coming under this category. So here we have two immiscible phases, means the two phases which are not miscible in each other, which are directly contacted. So in the second category we have two phases again, so which are separated by a thin membrane that acts as a barrier between the phases and also controls the transfer of mass between the phases. The third category is direct contact of miscible phases. Here the two phases are miscible in each other and their contact also results in some kind of separation. So how it occurs we'll discuss in the next session. The last category is use of surface phenomena, where some phenomena that exist at the surface of a fluid can be utilized to affect separation of components from the given substance. So let us now take up the first category and how the various operations are further categorized under subgroups and what are all the important applications of these operations. So as I said before, this category have mass transfer operations which involve two immiscible phases that are directly contacted with each other so that the material flows from one phase to another. So we all know that matter exists in three states, right? Solid, liquid and gas. So these three states of matter makes it possible to have 6 types of phase contacts. Okay, so we can contact gas with gas, we can contact liquid phase with gas phase, then we can contact solid phase with the gas phase, then we can contact liquid with the liquid phase itself, then liquid to solid phase contact, we have gas solid to solid contact. So let us now see what are the operations coming under each type of phase contact. The first category, gas to gas contact, where this type of contact is not practically realized because almost all gases are completely soluble. See, in this kind of operations, we require two immiscible phases, right? So since the solids, gases are always soluble in each other, So we can't realize any practical applications under this category. Okay. The next one, solid gas to liquid category, the most important category in this topic. So which includes the important operations like distillation, absorption, desorption, humidification, dehumidification. So we will see the brief understanding of these operations in the next slide. So coming to gas solid category, we have operation of drying, gas adsorption. Then under liquid to liquid category, we have one operation, that is liquid extraction. Liquid to solid category has three important operations, that is crystallization, leaching and adsorption. The last one, solid to solid category, we don't see any industrial operations in this category because of very slow rates of diffusion observed in solid phases. So that is a brief overview of how the various operations are categorized under direct contact of immiscible phases. So let us take up the gas liquid category. So understand the important operations under this category. First one is fractional distillation or simply distillation, an operation where a liquid mixture is subjected to separation by the use of thermal energy. That is, the given liquid mixture is heated so that the vapor is produced to create another phase. The vapor and liquid phases are then contacted in a suitable manner so that the vapor gets enriched in a single component which can be taken out as a product. So this is how we separate the crude petroleum, which is a mixture of various components like gasoline, kerosene, fuel oil, lubricating stock, etc., into its components. So this is a very typical important application of distillation, so which we see in various refineries. So then comes the second important application operation under gas liquid category. It is the gas absorption. So as we have already discussed in previous slides about absorption, it's an operation involving the contact of a gas mixture with a liquid solvent where the components of gas are transferred into liquid phase, thereby achieving their separation from the original mixture. So one important application of gas absorption is how we remove sulfur dioxide, which is an harmful gas, from the flue gases before it's being discarded from the plant. So this is carried out using alkaline solutions as a solvent. When the mixture of flue gases are contacted with alkaline solutions, the sulfur dioxide gets absorbed in the alkaline solutions, thereby that is getting separated from the gases, mixture of gases, that is flue gases. So next, desorption is a reversal of absorption operation. That is, if you contact a gas with a mixture liquid solution, if a component gets transferred from solution to gas, then the operation is called as desorption or stripping. Humidification and dehumidification are the operations that involve the transfer of material between a fixed gas and a pure liquid phase. So that means the liquid phase is always a single component phase. So we don't see any resistance to transfer within the liquid phase. So example is, if you contact dry air with water, then some of the water may get vaporized and diffused into the air. So this operation is called humidification. On the other hand, if you contact wet air with water, some moisture present in air gets condensed and added to water. So that operation is called dehumidification. So important operations under gas to solid category are drying and gas adsorption. So drying is that operation that is used for removing moisture from wet substances, wet solid substances. Okay, here the drying is achieved by contacting the wet substance with a gas, usually air, so which transfers heat to the moisture, thereby causing its evaporation. Once the evaporated moisture comes out, it will be carried away by the same gas. So that is how we can dry a wet filter cake. I know you know what is a wet filter cake, right? After filtration we get a cake, so that is having some amount of liquid. Okay, if you want the filter cake in dry form, we can keep it in a drying equipment, contact it with a stream of dry hot gas, so which heats up the material, thereby the moisture gets evaporated and that vaporized moisture is removed by the same drying gas, which is called drying medium. Okay, so this is an important application of drying operation. So then gas adsorption is that operation when a gas mixture is contacted with a solid adsorbent particles. So some mixed components from gas are concentrating on the surface of the solid adsorbent particles, thereby they are getting separated. For example, if you contact moist air with silica gel particles, okay, then the water present in air gets concentrated on the surface of silica gel particles because the adsorptivity of the water molecules on silica gel surface is more. So that is how the air in the surrounding gets dried. So that is an application of gas adsorption. Coming to liquid-liquid extraction. So this is an operation involving the contact of two immiscible liquid phases, and the objective is to separate the components of one liquid phase. It is to remove one or more components from a liquid phase. Okay. Example for this is separation of penicillin from fermentation mixture using butyl acetate as the solvent. See, here the fermentation mixture is also a liquid, then butyl acetate is also a liquid, but they are immiscible in each other. So when the two are contacted, due to solubility of penicillin in butyl acetate, it gets transferred from the original fermentation mixture to butyl acetate. That is how you can separate out the product from a mixture using liquid extraction operation. So coming to the last category, liquid to solid, here we have crystallization, leaching and adsorption. So crystallization is that operation which involves producing materials in solid form. It is formation of solid crystals from a liquid solution is what is called as crystallization. So coming to applications, see in the sugar manufacture, the end product is sugar solution, not the solid sugar. So it's required that sugar to be in solid form. So if you carry out the crystallization operation on the solution obtained, then the sugar comes out in the form of crystals. So that is what is known as crystallization. So coming to leaching, which is also known as solid extraction, it is an operation which involves the separation of components of a solid mixture by contacting that with a suitable immiscible liquid solvent. The solvent selected dissolves the particular component from the solid mixture which is need to be separated. So that is how separation is achieved in leaching. So for example, many minerals that are occurring in nature are not in pure form. Okay, they are existing in the form of ores which contains huge quantities of unwanted material. So if you contact the ores with suitable solvent, then it will only dissolve the required mineral, leaving out all other unwanted substances. So that is how separation of gold from gold ore is done using cyanide, that is sodium cyanide solution. Here the sodium cyanide solution acts as a solvent and it dissolves only gold from the gold ore. So that is how we extract metals from ores. So coming to adsorption, so we have one application here. It is how the sugar solution is decolorized using activated charcoal as adsorbent material. Okay. So here the contact is between a liquid solution and a solid adsorbent particles. So since the concentration of certain substances from liquid can occur on a suitable solid adsorbent, so we can contact the two in a suitable manner, then the required component needs to be separated. So sugar solution what you get at the end is impure with some color substances. If you want to remove that unwanted color, use a suitable adsorbent like activated charcoal, so which is added to solution, and all the color causing substances will get concentrated on the adsorbent particles. Thereby the unwanted color can be removed from the sugar solution before it's being subjected to crystallization. So these are the applications. So what we see under the direct contact of two immiscible phases. So we'll discuss the other categories of mass transfers in the next session. So let us have a quick recap of what we discussed today. So we initially learnt what are mass transfer operations, what are the importance of mass transfer operation, and how the mass transfer operations are carried out. So next we learnt how the mass transfer operations are classified under different categories. Also, we discussed important operations under the direct contact of two immiscible phases category. So we've seen some industrial applications of these operations also in the particulars in the present session. Yeah. So that's all for today's session. So thank you for listening. So we will again meet in the second session where we are going to discuss about the other categories of mass transfer operations, that is membrane separations, then direct contact of miscible phases, and also we'll be discussing about the diffusion mass transfer. Thank you.